Okay, so we have this. And let's angle it so you can see stuff. Okay, angle it more. Hey, it's Antechamber from Team 80110H, or the TVA, the Alliance thingy. And today I'm going to be going over, god damn it, we're going to be going over my ideas on how we can figure out the distances, well, where we are relative to, well, on the field. God fucking damn it, stay, please. You were staying for like 30 minutes before. This is my third take. And this is like the first time you've fallen down. Which is why I had to end the other take. Okay. So let's just extend this field of view, I guess. And erase stuff inside of this. So can you see that bottom line? All right, we can go a little further down. Okay, so then the top is at the flags. Okay, so we have our field of view, right? Okay, so let me do a couple things really quick. So just labeling stuff. Let's do orange, I guess. So we have top flag, the middle flag, and the bottom flag, okay? BOT, yeah, okay, that's correct. So that's what these colors will be from now on, okay? Okay, so what we'll first do is get the a little bit of the kinks out of the camera, because of how cameras work. Essentially, if we have a coordinate grid like this being our camera's vision, and if we have our camera, and let's say we have a point here, 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 and here, so these are all at equal, so all the angles here, the distance, well, the angles between these two lines, and these two lines, and these two lines are all the same, okay? So even if we do that, even if that's perfect, what will happen is that since we have our 4 lines there, let's make that 5 for reference, these are still the same, okay? So we might have a second one that's like here. That'd be this one. We have a third one that's like here. And we have a fourth one. And we have a fifth one. And as you can see, after I'd drawn this, I did not mess up. I did this on purpose. You'll see that as the lines get closer to the edge here, they get closer together. Not exponentially, infinitely, and horribly, but it is still there, where this isn't perfect. And the problem with that is that we cannot just say x coordinate, times a value equals the angle. We cannot do that. So what we can do then is calibrate for our specific camera that we're using, and hopefully all the cameras that Vex sells will be at least mostly the same values for these, but it will differ a lot, especially, well, from camera to camera, especially with pinhole cameras, which is what the E5 uses, which sucks. So what we can do is basically remap the values. So for like this line here, I'll just draw it because I can. So this will be our original image that the camera sees. And what we'll do is that we will stretch it along this axis. And that also applies to the vertical axis. So what we'll do as well is we will stretch our vision field thingy along the vertical and horizontal axis. So before, we would have lines that get closer and closer as they get to edge. Okay, like this. But now, after we've done this, all the lines will be evenly spaced. which means for any x and y coordinate on this field here, we'll just return a perfect and correct angle for what we're seeing. And then let's just do some simple math to do that, hopefully. So now, for any x and y coordinate that this is on, we can calculate the distance. So what can we do with this? So we know that the top, the middle, and the bottom flag are all at the same height always, and our camera, if you're not stupid, will be at the same height always. So what we can do with this is that depending on how far away the camera is, the angle between, for example, this, the camera, and that, the top flag, will get more steep the closer you get. And using some simple trigonometry, we can figure out, depending on what the angle like this is, what this angle is to the top flag, we can figure out what our, I'll call for now, the x-coordinate is. So the x-coordinate can be determined by the angle between the camera on the x-coordinate and whatever flag you're looking at. So, with that in mind, we can now, wherever we are, plot exactly where the flags are. So, let's see, let me draw a border. So if we have our, so what we'll do is we will have our thing, I messed this up, so top, our G, B. First one should be red. Okay, so top, middle, bottom. Okay, so now what we can do is, let's imagine we point, so if we have our cam at the middle between here and at 0 on this coordinate, if we point a ray with the angle that is on the x-coordinate on the camera, and at a, and then what we'll do is we'll do the trigonometry to figure out the distance to all these points. We can then, that exact distance, following this line away, we can plot the point. So that means that obviously there'll be some variances between all of them, all the flags, and we'll fix that and make it better in a later step. Let me get my three colors. R, G, B. Okay, so let's say our flag values for the middle flag are like here, here, and here. And then we have our flag values like here, here, and here. And here, here, and here. Okay, so what we can now do is run this through a formula that will calculate the line of best fit. So essentially, what this will do is it will return an equation, y equals mx plus b, that will draw a line that best and most closely approximates the position of these. So now, what we will do is, the next step will be to calculate a third point. So, so this will be the average of all these, their x and y coordinates that we get. So that works, but what we can also do is, instead of doing it for all these values and doing unnecessary math, we can speed it up a little bit by just taking our average values on the x and y coordinates for all these, and plotting them like this, and then using the line of best fit algorithm, we will make that yellow, I guess. So from now on, the line of best fit line of best fit, y equals m plus b. You can't really see that, but who cares? I can see it. and this is just a video for me. I'm probably only going to release it to my alliance and then never to anybody else. Okay, if they want to listen. So this is the line of best fit compared to these, okay? So now what we'll do is we figured out the distance on all of these. And what we'll do is, words, I can't word very well, sorry. Yeah, so we'll then take the average x-coordinate of all these values. So let's see, I'm gonna put the used colors over here, I guess. So then we have pink. So pink will be the average. The average will be the average of these averages, which will give us a center point, which, not surprisingly, should be exactly on this line. Yeah. Anyway, now that we have the average, what we can do is, let's see. So if our camera is here, for instance, and we've traced lines to here, here, and here, these are not actually going to be perfect because of reasons. So what we'll do is we will then take the average as our very center point. Sorry, just the average as our center point. And then we will have one new color, which will form, wait, let me show you how to calculate this. So if we have the distance between here, we will average that. The distances between here and here and here and here. And then what we'll do is we will plot 2 points, for example, here and here, that are the same distance to the center point. So what we've done now is we have taken 9 irregular points that roughly follow a line, and we've put 3 points on a line that's perfect, okay? Okay, so let me get rid of this stuff because it'll get in the way. And then I'll redraw these lines. This one and this one. Okay, and I'll redraw these colors. What did I do here? The average is this color. And I'll start reusing colors now because I'm pretty much out. Actually, I probably have more somewhere. Let me just grab those really quick. Ooh, there's a black one. Okay. I have 3 more colors. Actually, 2 more. I know, fucking 3. This one's might be very similar. Anyway, so I have 3 more colors. The problem is that these lines no longer perfectly match up with our perfect points. Those no longer match up with our perfect points, which are these and this. So we'll just color that orange too. So those are perfect points, but these no longer directly trace to these. So there's probably some formula for this that I don't know at all, and I don't really know how to find it. But the idea is the formula would go like this. And I know how I'd solve it using a protractor and compass and crap. So we know the distance to these, right? So what we'll do is we will have our distance here. I'll actually make that a different color. A new color known as vibrant green. So we have our distances like so. Right? And then what we'll do is that we will trace a circle along all of these. God, these don't match up at all, do they? Right, let me just... So if we... Wait, well, the point is, so we're going to trace a circle around that one, trace a circle around that one, trace a circle around this one. None of those really match up, but we have this triangle here, right? So this triangle has a center of that triangle, and we will erase this triangle for now and name it the magic triangle. The magic triangle, which is now purple, magic triangle is in the center of all these and has a point. Because I'm running out of colors, I'll just make it the magical triangle / point, which gives us this central point here, which is where our camera is. Or it's the closest approximation we can make with the data that I have in the way that I know how to do it. Because I haven't taken trigonometry officially or statistics officially or anything like that. Essentially, we have this. Yeah, it's not actually technically a triangle, but shush. We can just calculate the intersections and make it a triangle. There. So we have our magic triangle, and now what we know we have is, I can find an eraser. Actually, I don't need one. So we've calculated the magic triangle using all that. So our magic point or triangle is here, but until like now, we've been using this perspective, the perspective of the camera from where the points are for the flags, right? So we have to fix that. So we'll draw our line of best fit. And again, I don't know a perfect formula for this. If anyone knows it, please let me know. So we have our magic triangle, we have our 3 points, we have our line of best fit, and then essentially what we'll do is, this is our old grid coordinate plane, and what we'll do is that we will then keep the points in the same position, draw the grid with the flags in their relative positions on the square 12-foot by 12-foot grid. And then our magic triangle / point is exactly where everything is. And I guess we can measure what this angle difference is, and then we will get a vector. So magical triangle, point, vector, which will also give us an angle between this. But essentially what we've done here is that, to the best of my knowledge, this is the best way. Well, I can probably shorten the equations quite a bit. This is the most accurate way to find the magic triangle point vector inside of a grid, which is the entire field, based off of random data, well, semi-randomized data from where flags are. And yeah, I guess I'll just start programming that. Yep.